So in the last class, we have seen the multiple regression. But today we will see about the logistic regression, that is in linear regression and multiple regression deals with the continuous function, that is with the continuous data. And in case of the logistic regression, it starts with the classification problem where we will see the various discrete function. So since the logistic regression is basically a
Your
classification
screen
problem,
is not visible.
since the logistic regression deals with the classification problem, hence the function we will deals with is a discrete function. All we are the different techniques of the machine learning. What are the different functions of machine learning? That is starting from the regression analysis up to the last part, that is up to the decision tree. All are basically the supervised machine learning. We are dealing with a target value with respect to the predictor value. There are many predictors value and one target value. Now this predictor value and the target value, what we are dealing with in case of the machine, in case of the supervised machine learning, it deals with the two kinds of function. One is a continuous function, another is the discrete function. Now from here, the linear and multiple linear regression or regression analysis deals with the continuous function. From today onwards, that is from the logistic regression, we will deals with the discrete function. After that, the random forest, which is also a classification problem, which is also deals with a discrete function. Another one is the decision tree, the k nearest neighbor, KNN. So all are basically the classification problem, and it deals with the discrete function. That is not a continuous function. All are discrete in a discrete function. So today we will start with the logistic regression. So is it visible? Is it visible to you? Is it visible to you?
Yes, sir.
So this is an article of the logistic regression using the datacam article, and uh, we will see what is the logistic regression, how logistic regression differs with linear regression, and the different estimation methods, the sigmoid function, types of logistic regression, then modeling. That is coming to the coding section. Right, model evaluation. Another is the confusion matrix, heat map. We will all see these things. So this is basically an outline. Receiver operating characteristics, we will also see this one. These are not so much necessary for development of projects. So these things we will see all this. So coming to this section, Uh, so this is, as I told you, that logistic regression is basically a classification, is one of the classification techniques where we define the two classes, and the two classes are classified uh, by the regression analysis, and that is the two classes. We can separate the two classes by regression analysis, and that is named as the logistic regression. So this is a classification technique are the essential part of machine learning and data mining applications. And there are lots of classification problems that are available. As I told you, there are various classification problems which are available. Like the KNN, K nearest neighbor, is a classification problem. Decision tree is a classification for problem. Random forest is a classification problem. But all are based on the supervised machine learning. But the logistic regression is common and useful regression method for solving the binary classification. So apart from these random forest, decision tree, and uh, KNN, the logistic regression is most common one, and it is most feasible one rather than this decision tree, KNN, and random forest. So this is a very common method by which we can solve it as a binary classification problem, because that means it is dichotomous values. So this logistic regression, basically when we are talking about the binary classification problem, hence we are talking about this dichotomous values. That is, there are only two value, that is 0 and 1. So another category classification is a multinomial classification. Now, what is a multinomial classification? Which handles, it tells that which handles the issues where multiple classes are present in the target variable. So when there are more than two classes, or it may be a multinomial classification problem, right? So when there are multiple classes are present in the target variable, there then we called it as a multinomial classes. Here we are dealing with only one target variable, but when there are more than one target variable, then that kind of classification problem is a multinomial classification. So far we were dealing with the machine learning, that is the one target variable and more than one predictor variable, that is 2 to 3 predictor variable, and from that predictor variable we are analyzing the various regression analysis. But in a multinomial classification, we have more than two target variable, and from there we are developing a model. But logistic regression is not a multiple multinomial classification. Logistic regression deals with the one target variable. So it is not a multinomial classification problem. Both are the dichotomous, contains the dichotomous values, but those are the classification problem. But it logistic regression deals with the one target variable, not more than one target variable. Hence, it is not a multinomial classification. Logistic regression can be used for various classification problems such as spam detection, diabetics prediction, if a given customer will purchase a particular product or they will churn another competitor, whether the user will click on the given advertisement link or not. So these are basically the examples of the how the logistic regression, where we can apply it to the real time, in how logistic regression can be applied in a real time applications. So these are basically the different examples which are given over here. Logistic regression is one of the most simple and commonly used machine learning algorithm for two classes of classification. As I told you, because it is the most commonly used machine learning, because most of the machine learning in case of the supervised machine learning, which deals with the one target variable, and in case of the classification problem, we generally use the logistic regression where only one target variable and more than one predictor variable when we are doing any classification analysis. So in that case, the most popular one is the logistic regression. It is most feasible one. So hence it is most commonly used machine learning algorithm. It is easy to implement. Obviously, it is very much feasible than the other classification problem that I'm talking about, that is in KNN, the decision tree, random forest. From comparing to these classification problem, the logistic regression is most feasible one. So it is easy to implement and can be used for baseline for binary classification problem. Obviously, the logistic regression, as I told you, it deals with the binary classification problem. And it is a basic fundamental concept and constructive of the deep learning. From there, we for deep learning that is moving towards the other part of the machine learning. That is when we are moving towards the and the neural networks or other part of the machine learning. The it is a fundamental step where we will in the other part in the deep learning when we are using the concept of the binary classification is also useful in the deep learning, is also implemented in the deep learning. So it is hence it is so this it's a logistic regression is basically a fundamental concept for the constructive tool in the deep learning. Logistic regression describes and estimates the relationship. So yes, the regression means the estimation. When we are talking about the estimation, as we know that the regression deals with the estimation, the estimated value of the two things. So logistic regression obviously describes the estimation. What is the estimation? The estimation or the relationship between the two entities or the two variables, which mean that two variables may be dependent or independent variable. That is, X is dependent on Y or Y is dependent on X, or otherwise, in other terms, we can say that the two variables may be independent to each other. So a relationship and estimation, logistic regression obviously describes the estimation and the relationship between the two variables. So that is why it is telling over here that the logistic regression describes and estimates the relationship between one dependent and binary variable and then the independent variable. Now in this tutorial part, what are the introduction part? The introduction to logistic regression, linear regression versus logistic regression. That means I'm talking about this comparison of linear regression versus logistic regression. That is comparing a discrete function, a continuous function with the discrete function. As we know that the linear regression deals with the continuous function, but logistic regression deals with the discrete function. And we are comparing how the continuous function can be compared with the discrete function. That is why it is telling the linear regression versus logistic regression. Maximum likelihood of the estimation, ordinary least square method. We will see the estimation process, model building, that how the model can be built using the scikit-learn library, and the evaluation of the model, that is using by using a confusion matrix. Now what is confusion matrix we will discuss, and with the help of this confusion matrix we will evaluate the model, that is the how we will check the accuracy or level of the model, how much it is accurate of the model which I developed, how much it is accurate. That can be determined by this confusion matrix. So model evaluation, what is also analyze is also analyzed by this confusion matrix. We will also see that what are the advantages and disadvantages, a basic outline of the logistic regression, how do that will that is the we will see that how much the logistic regression is helpful for the real-time application. That is advantage and disadvantage we are talking about here, because we are talking about the advantages and disadvantages with respect to the linear regression. So everything has its own positive and negative negative output. So considering to that, comparing to that, how the logistic regression is more advantageous and disadvantageous with respect to the continuous function. Now, logistic regression is a statistical method for predicting the binary classes. All regression, the term regression itself is statistical analysis. Regression means the estimation. Estimation of what? Estimation of the two variables. And obviously it is one of the regression is one of the statistical tool or statistical method for prediction for predicting the binary classes. Regression means we can define it as an estimation, we can define it as a prediction. So it is the prediction of with respect to dependent variable or independent variable. So obviously a logistic regression is a statistical method for predicting the binary classes. The outcome or the target variable is dichotomous in nature. Dichotomous in nature means it is a binary in nature. That is, dichotomous means one and zeros. So dichotomous means there are two possible classes. That is, two possible classes. For example, it can be it can be used for the cancer detection problem. It computes the probability of the event occurrence. So there are two possible classes. Possible classes means the possible estimated classes. And depending on that, the dichotomic values are analyzed, and we are developing a logistic regression model. And this cancer detection problem is a real-time one of the real-time data set from which we are analyzing the logistic regression from that particular data set. And we will see these things on the later part. It computes the probability of the event occurrence. When we are talking about the regression analysis and when the regression deals with the prediction, obviously the term probability comes from, and obviously we compute it with the probability, and hence probability comes for the real-time applications. That is why we say that it computes the probability of an event occurrence for a particular event occurrence. It is a special case of linear regression where the target variable is categorical in nature. Hence, since we are dealing with, as I told you, that the logistic regression deals with a categorical or a categorical analysis or a binary classification problem. So obviously it is a categorical in nature. That means it may be a true or false, or it may be the outcome is the dichotomous in nature. Hence it is a categorical in nature. So target variable, what since we are talking about all the analysis we are doing with here is a supervised machine learning. So and since hence we are dealing with the target variable, and we are comparing with the with respect to the predictor variable, when we are developing a model from which we can analyze whether my model is correct or not, how much it is accurate or not. That has been determined by this target variable, and hence since the logistic regression is categorical or a binary classification problem, so the target variable should be a categorical one. It is a linear regression. Logistic regression is a linear regression, but it is categorical in nature. That is why it is called as a special case. And that is why it is telling over here that it is a special case of linear regression where target variable is categorical in nature. It uses the logs of odds as a dependent variable. Logistic regression predicts the probability of occurrence of a binary event utilizing the logit function. Right? So in a linear regression analysis, in a linear regression model or in linear regression equation, we know that y is equal to beta naught beta 0 plus beta 1 x1 plus beta 2 x2 plus beta n xn, where x1 x2 and this beta is basically the coefficient of x1 x2 and dot 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 xn. So this is a basically the equation of a multiple regression, right? It deals with the linear regression analysis where y is the dependent variable and x1 x2 are the explanatory variables. With respect to the explanatory variables, I am establishing the linear regression model. So, so how many predictors? So this x1, x2, x3, dot 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 xn. These are basically the predictor variables, and b1, beta 0, beta 1, beta 1, beta 2, beta 3, dot 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 beta n are the coefficient of the predictor variables, and beta 0 is the basically an intercept of the variable. A sigmoid function, when we are dealing with a binary classification problem, the it is very useful. We have to use this as sigmoid function, and this is the sigmoid function is defined by e is equal to 1 by 1 plus to the power minus y. So this is basically the sigmoid function. So in case of the sigmoid function, this is a kind of the sigmoid function. This is basically a sigmoid function, and this is linear regression. So this is basically a logistic regression. A curvature is over here. Yeah, a little curvature is over here, and it just touches the x-axis. So this is the equation of the sigmoid function. Applying this sigmoid function to on the linear regression, we are getting this form. We know that y is equal to this beta 0, beta 1, beta 2, x2 plus beta n. So we're putting just the value of y over here, and we are getting the resultant value of p, that is the probability or estimated value, is p is equal to 1 by 1 plus to the power beta 0 plus beta 1 x1 plus beta 2 x2 dot 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 beta n xn, which are basically the coefficients of the predictor variable. So this p is equal to 1 by 1 plus e to the power minus beta 0, beta 1, x1, beta 2, x2, dot dot beta n xn. This is basically the equation of a logistic regression. Now this we will compare how the linear function and the discrete function. Since this function has an exponential in nature, we are using an e function, that means it is exponential in nature. So the curve is exponentially, it rises and afterwards at a certain time it again gets tempered. It's tempered a certain period of time. So this is so it increases exponentially and then temper it. But here it is a ramp function. Basically, the linear regression is a ramp function. It continuously increases with the value of y increases with respect to the x in a continuous manner, and hence it is a straight line. So linear regression gives a continuous output. Continuous output, but logistic regression provides a constant output, right? Now, this logistic regression, another thing I want to mention over here, that logistic regression can be used for multi-class classification problem. It can also be used for multi-class classification problem. But it is mostly used in a binary classification problem, and is most or the popularly used in a binary classification problem, not in a multi-class classification, but it can be used also in a multi-class. So linear regression gives continuous output, but a logistic regression provides a constant output. And since it gives a constant output, hence we are getting this straight line. But in a logistic regression, since it gives a continuous output, hence we getting a certain curvature. And since by as per equation, it increases exponentially. So we get a certain curvature and afterwards it's at a certain point of time, it again tempered. So an example of continuous output is a house of price, stock price. But example of a discrete output is predicting whether the patient has cancer or not, predicting whether the customer will churn. Linear regression is estimated using the ordinary least square method. Therefore, there are various the model which I will develop using the logistic regression. It should be properly estimated by the different estimated, and this estimation is generally tested by the different kinds of methods. One is the ordinary least square method, OLS, while logistic regression can also be estimated using the maximum likelihood estimation. The maximum likelihood maximization cost method, and the OLS is a distance minimizing approximation. So one for the maximization, that is for the optimization or maximization, while OLS is distance minimizing approximation. So these basically two are the optimal techniques, and the maximizing the likelihood function determines the parameters that are most likely to produce the observed data. So these things are basically done after the model is developed, and when we are want to evaluate that particular model for the accuracy testing, we use this kind of the different methods for testing the accuracy. And uh, from statistical point of view, MLE sets the mean and the variance as parameters in determining the specific parametric value for the given model. This set of parameters can be used for predicting the data needed in a normal distribution. Ordinary least square estimates the computed of fitting the regression line on a given data points that has the minimum sum of the square deviation. See that the evaluation of the model which I developed is generally evaluated by all of these techniques. That is the MLE, that is the maximization method. Another is OLS for distance minimization. So least square method, we can also minimum sum of the square deviation, we can minimize it. So both are used to estimate the parameters of linear regression model. MLE assumes the joint probability mass function, while OLS does not require the stochastic administration, stochastic assumption for mining the distances, for minimizing the distances. So stochastic is joint probability mass function. That I will tell you, that is one of the probability techniques, and for MLE, and OLS does not require the stochastic assumption for minimizing the distance. So we didn't require for uh, minimizing the distance for another tool for minimizing the distance. Now this is a sigmoid function. As I told you, what is the sigmoid function? When we deal with the logistic regression, that is in a classification analysis, we will also always consider the sigmoid function, which is basically a nothing a logistic function. So as I told you that this is a curvature, so this curvature is defined by an S-shaped curve. So for mapping with 0, 1, 0 and 1, it can take any real value number. If the curve goes to positive infinity, the y predicted will become 1. So what we predict, what we analyze it, then if that is predicted truly, then my prediction is correct. So it gives, so the if the since the curve is uh, So my car so this is so my prediction is correct if the target value matches with my predicted value there, so my prediction is correct. So if the curve goes to the positive infinity, y will predicted as 1. If the curve goes to the negative infinity, the y will predicted as 0, since it is a classification problem. If the output of the sigmoid function is more than zero point 0.5, we can classify it as 1, or less than zero point 0.5, we classified it as 0. So we are setting the values when it will be 1, when it will be 0, and that is the nature of the supervised machine learning. A given data set will be given, you have to evaluate, you have to develop a model, and then after that we will evaluate the model, right? So here the two examples are given over here, the one for the yes, another for the no, since it is a classification problem and we are using one of the value that is in the 0. And if the predicted value is 1, the curve goes to the negative infinity. If predicted value is 0, the curve uh, if the curve will go to the positive infinity if the predicted value is 1, and the curve will goes to the negative infinity if the predicted value is becomes 0. If the output of the sigmoid function is more than zero point 0.5, so this is one of the example for the supervised machine learning while I am classifying the model when it will become 1 and when it will become 0. If it is in a positive infinity, then it becomes the predicted my prediction is 1, and if it goes to the negative infinity, my prediction will be termed as 0. If the output of the that means another example which is also given over here using one of the parameters of zero point 0.5. So if the output is more than zero point 0.5, we classify it as 1 or 0. And if the output is less than zero point 0.5, we classify it as 0. So if the output is 7.75, we can say that in terms of the probability, 75% chance the patient will recover. So this is the function fx is equal to 1 by 1 plus e to the power x minus x. So this is the function of the logistic regression. Now types of the logistic regression. So there are various types of logistic regression. One is the binary logistic regression, uh, where only two output, or where only the two possible outcomes that may come, true or false, since we are dealing with the classification analysis for this function. Multinomial class logistic regression, the target variable has three or more nominal categories, such as predicting the type of wine. So far we are dealing with the one predictor variable, one target variable. Now in a multinomial logistic regression, there may be more than one target variable. Ordinal logistic regression, the target variable has three or more ordinal categories, such as the restaurant or products, rating from 1 to 5. So far, any problem from anybody? Any problem? Any doubt? Any problem?
No, sir.
No, sir. So this part is same for any regression analysis. So if we see the database, so this part is same for any machine learning algorithm. This is the Just a minute. So this is the Kaggle. So this is a link where the real-time data is given, a data set is given. Click the link. So the data set is hidden. This is a data set that is so import pandas, column name, CSV file. All these things I had shown to you, and the same thing is also written over here. Then head, that is the PyMa. This is the data frame, and data frame dot head by default it gives the five first five values. So selecting the features, so this is one target variable and the predicted. Then after that, we are splitting the data. We split in the data into train set and test set for building the model and for testing. Using the same scikit scalar cross validation, train test split. So in the linear regression analysis, we don't use this cross validation, but here we use the cross validation. There also we use the train set and test set for building and evaluating a model. Model development and prediction, that means here we are creating the logistic regression. Then we use for evaluating the model. For model evaluation, we use the confusion matrix. Now, a confusion matrix in logistic regression analysis, we use the confusion matrix. That is, this is the confusion matrix. Confusion matrix deals with the four things: a true positive, true negative, false negative, false positive. Right. Now, if I say so, if I create the matrix and I'm dividing the column, this is TP, this is FT, this is FN, and this is TN. What is TP? TP stands for the true positive. True positive. Here in this logistic regression is a binary classification problem. So one should be 1 and another should be 0. So the true positive over here signifies that what we have classified, that is predicted as true. That what we are classifying about the median, then one should be one is the target variable, and what we another is predictor variable. If the predicted value matches with the target value, that is, if the predicted value matches with the actual value, then it is called as a true positive. That is, if we predict 1 and the actual value is also 1, or we can say that if 1 we have done with 119 classification and 100 what and it is appears as a true, then it is termed as true positive. That means, in one word, what we predict, if that predicted value matches with the actual value, then it is called true positive. If we move to the diagonal, so this is true positive and this is true negative. So for positive means that if I say my predicted value is 1, my actual value is 1, my predicted value is 1, then it is 2%. If my predicted value is, if my actual value is 0 and the predicted value is 0, then it is termed as true negative. After that, false negative. We predict as a 0, but they are actually 1. So the classification model which is established does not matches a single instance. So my classification should be cancelled. False positive means what we predict as 1, we predict as a 1, but it actually becomes 0. So that is false positive. Any problem? The true positive means how many positive classification is done correct. True negative, how many correct negative values what you are classifying. False positive means what we predict. We predict as 1, but actually it becomes 0. So this is false positive. And false negative means we predict as 0, but actually it is 1. That is false negative. Any problem? Any problem?
No, sir.
Now evaluating the model, after that we will see the visualization matrix and unit map using this code part. This is confusion matrix coding part. So precision is about to being precise. That is how accurate your model is. So precision means where we check the precision or positive predicted value, uh, what is defined as the percentage of true positive predicted amongst all the positive values present. So that is precision. So precision is same as the cumulative event rate. So it also checks that how accurate am our model. In other words, you can say when model makes the prediction, how often it is correct. In your prediction case, when your logistic regression model predicted patients are going to suffer from diabetes, the patients have 76% of the time. Considering the precision, we also use the accuracy. So what is accuracy? Accuracy means defined as the percentage of right classification. That means percentage of right classification in terms of saying that percentage of true positive and true negative detected, which is detected by the model from the entire data. So accuracy is defined as TP plus TN divided by TP plus FP plus false positive, that is, or true negative, or false negative into 100. So this is basically the accuracy for this. Sensitivity indicates how efficient the model is by identifying the events. That is the sensitivity. And sensitivity also measures the percentage of true positive predicted from all the actual positive values. That is called the sensitivity. So what we will see over here, yes. So recession, the formula is given by TP by TP plus FP into 100. This is for recession. Next is TP plus TN by TP plus Tn divided by TP plus Fp plus Tn plus Fn into 100. So this is measured for accuracy. Another is the sensitivity. Sensitivity is calculated as TP by TP plus Fn into 100. So these are basically the formulas of model evaluation. Precision is TP by TP plus 2 positive plus false positive into 100. Accuracy 2 positive plus 2 negative divided by all 2 positive plus false negative positive plus 2 negative plus false negative into 100. Now another thing is ROC. Another thing is ROC. ROC stands for the receiver operating characteristics. So this picture is incomplete. This picture is not completed. We know that the difference, the maximization of the difference denotes of the two lines or two entities is measured by accuracy. Now, when the accuracy is large, it is very difficult. That is the difference. If the difference between the two lines is very large, we are testing the accuracy. We take one line for linear regression, another line CD for linear regression, and after developing the model, we are trying to evaluate that particular model. And when we go on for evaluating that particular model, we use the different techniques like accuracy, precision, and the decision tree, and so on. If we say that the distance between the two lines is limited, then we can say, we can talk if the distance between the two lines is very is 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 very minimized, then the model is very much accurate. If the difference between the two lines or two entities is maximum, then we cannot say that the model is optimal model. If the model becomes optimal, if the difference between the two lines is very small for minimization, there should be a the model difference between the two lines should be minimal in order to evaluating the model, in order to evaluating the accuracy. So more the distance, the less the accuracy, and less the distance, the more the accuracy the model is. Here we are getting the car having the better model. Since in a linear classification, we build a linear line. More than an area we are having between the car, the more better the model is at. And that is why so more the area having between the car, the better the model is it. So more the deviation of the line, the better model is it. And this is termed as the area under curve or AUC. So when we say that AUC score is 1, which represents a perfect classifier, and 0.5 represents the best way for percentage for developing a model with perfect classifier, the best way to score is 86%. The best way to score the area under curve should be 86%. So the distance between the two cars is huge. The perfect is the classifier. So more the distance between the two cars, less is the classifier. That is, so more the distance, the more model is accurate model is achieved. And if so, the more the distance between the two lines or 2 points, the best is in the classifier, but less the distance between the two lines, it will be more accurate. So this is what the area under curve. So 86% score means score is 1, which represents a perfect classifier, but 0.5, so 1 represents the best or optimal classifier, but 0.5 represents the worthless classifier. Since the advantages, it is because of the efficient and straightforward in nature. doesn't require high computation power, easy to implement, easy to interpret, is widely used by data analysts and scientists. And the logistic regression obviously gives the possibility of scoring. The disadvantage is logistic regression is not able to handle the large number of categorical features, and obviously it is vulnerable to overfitting. Logistic regression does not so logistic regression is not able to handle the large number of categorical features or variables. It is vulnerable to overfitting when you want to fit that particular model in logistic regression. It generally becomes in the so any problem?
No, sir.
So in the concluding
No, sir.
part, this tutorial we covered. So this is we covered the logistic regression. So another thing is that so this is the theoretical part we discussed or outlined it. On the next day, that is on the Saturday, we will do the coding part of the logistic regression. Now, your class will be on Wednesday and Saturday every week at 9 p.m. I think it is visible to you all.
Yes, sir.
So your class will be on the 2 days in a week, that is on the Wednesday and Saturday, and from 9 p.m. on.
9 p.m. From 9 p.m., sir?
Yes, from 9 p.m.
Okay.
So today I am stopping over here and I will share this material to you, and next day we will code the logistic regression, that is on Saturday. Okay.
Yes.